students, welcome to the digital class of mathematics. Today in our first session, we will learn about the chapter rational numbers. But before starting with the concept of rational numbers, let's recapitulate what are natural numbers, whole numbers and integers. So natural number. Natural numbers are the counting numbers. And as we know that counting starts from 1, 2, 3, 4 and so on. So, natural numbers are counting numbers. Whole numbers. If we include 0 to the set of natural numbers, it becomes whole numbers. So, if we include 0 to the set of natural numbers, it becomes whole number. So now 0, 1, 2, 3, 4 and so on. They all are whole numbers. And if we talk about the negative numbers, -3, -2, -1 and so on. So this whole set of numbers will become integers. So natural numbers are counting numbers and counting starts from 1, 2, 3, 4 and so on. 0 and 1, 2, 3, 4 so on are the whole numbers. And negative numbers -3, -2, -1, the 0, 1, 2, 3, 4 and all these numbers will become integers. So now let's learn about the concept of rational numbers. So a number that can be expressed in the form of P by Q, where P and Q, they are integers and Q is not equals to 0 is called a rational number. So any number which can be expressed in the form of P by Q. So we can take example like 2 by 3. 2 by 3 is a rational number. -5 by 4. It is also a rational number. -7 by 100 is also a rational number. 0 by 7 is also a rational number. Only number 3 is also a rational number because this can be expressed as 3 by 1. We know that 3 by 1 is equals to 3 only. So, 3 is also a rational number. But there is one condition in rational number that Q is not equals to 0. It means that the denominator cannot be 0. 0 by 7 is a rational number. But 7 by 0 is not a rational number. Now, coming to the properties of rational number. The first property is the closure property. Closure property of rational number. The closure property of rational number holds true only in the case of addition, subtraction and multiplication. Not in the case of division. What we say in a closure property that if we add, subtract and multiply two rational numbers, the resultant will also be a rational number. Again I say, if we add, subtract and multiply two rational number, the resultant number will also be a rational number. Let's take few examples and verify these properties. So if I take the first rational number to be 2 by 5 and I am adding it to the another rational number of supposingly 1 by 5. So 2 by 5 plus 1 by 5 is equals to 3 by 5, which is again a rational number. Let's see in the case of subtraction. 2 by 5 minus 1 by 5. So it will be 1 by 5 and 1 by 5 is also a rational number. And let's see in the case of multiplication. If I consider these two numbers only, 2 by 5 multiplied by 1 by 5. So 2 into 1 is 2 and 5 into 5 is 25, which is again a rational number. So, in closure property, we say that if we add, subtract and multiply any two rational numbers, the resultant number will also be a rational number. But this closure property does not hold true in the case of division. Let's take an example. So consider one of the rational number to be 2 by 5 and another rational number to be 0 by 5. So in case of division, we change the sign to multiply and reciprocal the next fraction. So it will be 5 by 0. 5 and 5 will get cancelled. The answer will be 2 by 0. And as we know the concept of rational numbers, that Q, that in denominator, the denominator cannot be 0. So that means this is not a rational number. The second property is the commutative property of rational number. In commutative property of rational number, students, we say that if we interchange the position of the numbers, their product and their sum remain the same. Again, if we interchange the position of the numbers, their sum and their product remain the same. Let's verify this with example. So if 3 by 7, if I add this with 11 by 7, it will be 7, 3 plus 11. So 3 plus 11 is 14. So 14 by 7 is the answer, or 7 ones the 7, 7 twos the 14. So the answer is 2. So now let's add 7 by 11 with 3 by 7. So the denominator will be 7. It will be 11 plus 3. 11 plus 3 is again 14. So 14 by 7. 7 1, 7 2. So it is again 2. So this is also 2. This is also 2. That means this commutative property holds true in the case of addition. Now let's see in multiplication. If I consider these two numbers only, 3 by 7 multiply by 11 by 7. So 3 into 11 is 33 and 7 into 7 is 49. And now if I multiply 11 by 7 into 3 by 7. 11 by 7 into 3 by 7. So it will be again 33 by 49. So these are the same. So we can say that the commutative property of a rational number holds true only in the case of addition and multiplication, but not in the case of subtraction and division. So the third property is associative property of rational number. In associative property of rational number, let's consider three rational numbers. So the first rational number is a by b. The second rational number is c by d. And the third rational number is e by f. A by b is the first rational number, c by d is the second rational number, and e by f is the third rational number. If I group a by b and c by d and add them and add their answer to e by f, it will be same if I add first c by d with e by f and its answer to a by b. That means in a very simple language, if 1, 2 and 3, these are the three rational numbers. If I add first and second rational number and then its result to the third one, it will be the same if I add second and third rational number and its answer to the first one. This property holds true in the case of addition as well as in multiplication. That means if I multiply first and the second rational number and its answer I multiply with the third one, it will be the same if I multiply first the second and the third rational number and its answer with the first rational number. So this is the associative property of a rational number. Let's verify by taking examples. So let's take 3 rational numbers. Supposing the rational numbers are 2 by 7, 3 by 7 and 5 by 7. These are my 3 rational numbers. So first let's see the first one, the addition one. So it will be 2 by 7 plus 3 by 7 plus 5 by 7. So let's add them. 2 by 7 plus 3 by 7. It will be what? 5 by 7. Now 5 by 7 plus 5 by 7. My answer is 10 by 7. Right? Now let's verify the right hand side. So it is 2 by 7 plus bracket 3 by 7 plus 5 by 7. So 3 by 7 plus 5 by 7. So the answer is 8 by 7. So 2 by 7 plus 8 by 7. It is again 10 by 7. So both the LHS and RHS is same. So this property holds true in the case of addition. Similarly, you can take the example for multiplication as well. So in multiply, first we need to multiply these 2 rational numbers and its answer to the third one. So let's see. If I multiply 2 by 7 with 3 by 7 and its answer with 5 by 7. So this will be what? 2 into 3 is 6 and 7 into 7 is 49. So it will be 6 by 49 into 5 by 7. So 6 by into 5 and next we have 49 into 7. So 6 5s are 30 and 49 into 7 is 343. So the product is 343. Now let's verify by taking the right hand side. So right hand side we have 2 by 7 multiply bracket 3 by 7 into 5 by 7. So it will be 2 by 7 will be the same. Will remain same. Now multiply 3 with 5. 3 5s are 15 and 7 into 7 is 49. So now we have 2 by 7 into 15 by 49. So 2 into 15 is 30 and 7 into 49 is 343. So they are same now. So now we say that in associative property of a rational number, if we add the first and the second rational number answer to the third rational number, it will be same if I add second and third first and its answer to the first one. And in multiplication again the same. If I multiply first and the second rational number, its answer with the third one will be the same if I multiply second and third one to the first one. So this is your associative property of rational number. The fourth property is the distributive property of rational number. So the first one is distributive property of multiplication. Distributive property of multiplication over addition. You have already learned this property for whole numbers as well. Let's consider 3 rational numbers. So A is my first rational number, B is the second rational number and C is the third rational number. So in distributive property of multiplication over addition, we say that A multiplied by B plus C is equals to A multiplied by B plus A multiplied by C. This is the distributive property of multiplication over addition. If A, B and C are the 3 rational numbers, then we say that A multiplied by within a bracket B plus C is equals to A multiplied with B plus A multiplied C. The another one is distributive property. Distributive property of multiplication over subtraction. So in this we say that A multiplied by bracket B minus C. Again A, B, C, these are the three rational numbers. This is equal to A multiplied by B minus A multiplied by C. So this is the distributive property of rational number over addition and over subtraction. The fifth property is the role of 1. In this we say that if we multiply any rational number with 1, the answer is the same rational number. If I consider A to be one of the rational number and I multiply it with 1, it will be A only. Let's consider an example. So it's 2 by 3 is a rational number. If I multiply it with 1, my answer will be 2 by 3. So this is the role of 1 in the rational number. The next property is the additive inverse. In additive inverse, we say that for a rational number A, minus A is the additive inverse of A. Again I say, for a rational number A, minus A is the additive inverse of A, if A is a rational number. For example, if I talk about the additive inverse of 2 by 3. 2 by 3 additive inverse will be minus 2 by 3. And if I take a negative rational number, supposingly minus 5 by 7, its additive inverse will be 5 by 7. So simply we can say that if I have to find out the additive inverse of a rational number, if it is a positive rational number, its additive inverse will be a negative. It's negative. And if it is a negative rational number, its additive inverse will be its positive. So if I take another example, 5 by 11. Its additive inverse will be minus 5 by 11. And if I say 1 upon 10, minus 1 upon 10, its additive inverse will be 1 by 10. So thus we can say that for every rational number A plus minus A, that means the rational number and its additive inverse, their sum will be 0. If I add 2 by 3 with minus 2 by 3, it will become 0. Or minus 5 by 7 plus 5 by 7, it will become 0. So we can say that 0 is called the identity for the addition of rational numbers. Again I say 0 is called the identity for the addition of rational numbers. So in additive inverse, we say that for a rational number A, minus A is the additive inverse of A. That means a positive rational number, its additive inverse will be negative, and for a negative rational number, its additive inverse will be its positive. So now let's come to the next property, the multiplicative inverse. In multiplicative inverse, we say that for a rational number A, 1 by A is the multiplicative inverse of A. It simply means that if I talk about a rational number, for example 2 by 7, its multiplicative inverse will be 7 by 2. Just its reciprocal. If it is a negative rational number, minus 2 by 7, its multiplicative inverse will be 7 by minus 2, or you can say that minus 7 by 2. As we know, we never write the negative sign in denominator. So, thus in multiplicative inverse, we say that A multiply with 1 by A. That means if I multiply a rational number with its multiplicative inverse, or you can say it's reciprocal, the answer will be 1. Let's see an example. If I multiply 2 by 7 with 7 by 2. So 7 and 7 will get cancelled. 2 and 2 will get cancelled. And my answer will be 1. So 1 is the multiplicative identity for rational number. Like we say that 0 is the identity for addition of rational number, and 1 is the multiplicative identity for rational number.